We will discuss about a use case called reducing customer churn for a telecom company, and this is a course project for the managing machine learning projects as part of the AI product management specialization. So moving on, in this competitive telecom industry, customer churn is a very crucial issue because it has real implications for the annual revenue of customers, and it also leaves the brand in a negative light, and because telcos have a lot of customer data at their disposal, they are in a perfect situation to make use of their customer data they have and to implement a machine learning model which can classify a customer as a probable churn, and in which case the telco can have a proactive plan in place. So moving on, for an opportunity evaluation perspective, there is quite a lot of things that telco needs to consider, like revenue loss or increased CAC, customer acquisition cost, and negative impact on the brand reputation. And if the telco is able to solve this problem, if they can even come up with a 10% reduction in churn, it increases their revenue and also the brand in the market. So this is a perfect opportunity for the customer, for the telco to be picking up. And from a crisp DM business understanding, so basically the problem is beyond the direct revenue impact. All the dissatisfied customers, they give the telco lower NPS scores, and the CAC is approximately 1.5 times of the cost of keeping the existing customers. So how do we evaluate if we have solved this problem or not? I think the business outcome should be that we should be aiming for a 15% decrease from the current churn rate of the telco, and this means an annual revenue increase of 75 million, and which also has a very non-tangible impact of increasing the brand value. And from a machine learning model algorithm, we will have the output metric as area under ROC curve to be greater than 0.9. Yeah, moving on. And the potentially relevant features. So what are all the things that the model will take into consideration to arrive at a prediction? Will be the customer demographics, service usage patterns, their billing history, and the customer support interactions, which will be the number of support tickets the customer has raised, what kind of interactions the customer has had, what was the NPS score the customer has given for the touch points, various touch points the customer has had. So all these are the potentially relevant features which are available with the telco, and but which further need to be drilled down to arrive at the final feature set. Now coming to the model selection and validation, because this is a classification problem, we need a binary classification where we are saying that we need to know if the customer is a probable churn or not. So we will go with a logistic regression, and the target classes will be potential churn, and the threshold will be 0.5, above which the predictive value will be classified as a 1. So moving on, feature engineering, like when we went back to the relevant features, so we will take all those features and then we will look at if there's any missing data, and then we'll use a simple heuristic model to predict the missing value, and then the data will be analyzed to look at the outliers, and once these outliers are flagged, they will go through a manual analysis. For the first couple of times, the data is cleaned and prepared for the modeling to make sure that these outliers are indeed valid. And if they are not valid, they will be removed from the data set. And if they are valid, then we need to be clear on how these outliers are going to impact the model. And we need to iteratively go back and look if logistic regression is the correct model or not. But that is going to come once we basically analyze the outliers. So once the outliers are analyzed, we do a feature selection based on the filter method. Filter method involves, because we have a huge customer base, we can just go with the statistical methods, which is inexpensive and also relatively faster, such as correlation analysis and chi-square tests, to remove the unwanted features. So after the feature selection engineering, we will end up with a data set which is cleaned, and these features are what we think are basically needed for the model to predict. And now coming to the training and evaluation plan, we will do 80 to 20% between training and validation, and 20% we will leave it alone for testing. We need to ensure there is no data leakage, and this 20% left for testing is not utilized anywhere in the training and validation. So for the training and validation, we take the 80% of the data and do a 8-fold k-cross validation, which means that we will have 1/8 of the data, the entire data, for validation for every run, and this one eighth of it will be keep 1/10 of it will keep changing for every run, which means that we have a different validation set, which further ensures that we are basically validating the model quite well. Now, if we need to further check within logistic regression, there is two hyperparameters. We can further go and experiment. They are lasso and rich. We use both these variations, and when we run the models to check which model is performing better after the validation, and whichever model is performing better, that will be further trained on the 20% left for testing. And then coming to the experiments which we will do for the model training and evaluation, we will hold out the random subset of the most recent 60 days terminated subscribers. So we can have an unbiased testing towards the historical training patterns, and we will also interview sample model high risk predictions to refine feature engineering and behavioral assumptions of most at the risk groups. Coming to the system design, so there are three main system design decisions that needs to be taken before implementing the model. So cloud versus edge, these are very straightforward decisions. We will go with a cloud model with an offline learning and a batch prediction, because fundamentally this model is not exposed to the end customer of the telco. This is a model that will typically be used by a customer success or an operations or marketing department. The end receiving department of the model output will be a marketing department with a list of users who are a potential churners, who will then come up with a proactive plan to basically retain these users. And these are not the behaviors that will be changing very often, and this is not a very high interactive online or social media model. This model basically works on the data that is already collected in the system from some months or years. So a fortnight I consider is a good duration to train the model, and the predictions can be batch because we can then deliver the results to the marketing team. Coming to the potential risks in production, there is the first thing is the concept drift, because sometimes we have seen that telcos have a change in strategy whereby they purposely want to shed a certain section of users in which the churn will be expected, and in which cases this model will start to predict a very high number of users as churn. In this case, the model needs to be revisited. And in the second case, the data drift, because of the way the customer behavior will change and the churn patterns will also change over time. The model needs to be periodically retrained and monitored, and the outputs need to be audited from time to time to make sure that the model performance, once the model performance threshold is reached and the model is no more accurate beyond, let's say, 85%, we go back and retrain the model and hence bring it back to the original performance. Thank you so much and have a good day.